It says two pictures are mathematically similar in size. That one's 100 centimetres, that one is 60 centimetres. The cost of each picture is proportional to its area. There's the important bit there. The large picture costs £13.75. Find the cost of the smaller picture. Right, first thing we're going to do is we're going to work out scale factor. As soon as you see something and it talks about things being similar, then it's scale factors we're talking about. So scale factor K is equal to shape 2 divided by shape 1. Now, it's the smaller one we want to find, so shape 2 is the smaller one, which is 60 divided by 100. The smaller number goes on top. Now, when I break all of that down, it's the same as 6 over 10, which is the same as 3 over 5. Now, we're talking about area. It's all about area, so we want the area factor. So area factor is K squared. Area is measured in squares, so it's K squared. So therefore the area factor is equal to 3 over 5 all squared. Now square the top, square the bottom, which is the same as 9 over 25. Now we want to work out the cost, but it's proportional to the area. So the cost of the small one is going to be the area factor multiplied by the cost of the bigger one. So it's 9 over 25 multiplied by £13.75. So to work that out, multiply across the top 9 times £13.75 and divide your final answer by 25 and you get a cost of £4.95. Now that makes sense. The bigger one was £13.75, the smaller one is going to be cheaper. For this one we want to change the subject of the formula to K. Now I'm going to read it round the other way. So we've got 4 K times T minus P is equal to L. Now everything is stuck under that square root sign. The K is under there, so the first thing I've got to do is get rid of that square root sign, and the opposite of a square root is to square both sides. So when I square that side I get 4KT minus P is equal to square the other side is L squared. Now when I say this, I've got 4KT minus P. The last thing I said was take away P, so I do the opposite and I add P onto both sides. So 4KT is equal to L squared plus P. And the last step is I want to leave K on its own. I want to leave that K there. That's what I'm changing it to. Now what's with it? There's a 4t with it, and they're all being multiplied together. So the opposite of 4 times k, or k times t, is to divide. And when we divide that, we can do it in one step. And when we divide, it goes down to the bottom of a fraction. So that 4t goes down to the bottom. I'm now going to express this algebraic fraction as a fraction in its simplest form. So the first thing we're going to do is we're going to take a common denominator for both of these fractions. Now we've got x minus 2 and x plus 1, so we multiply both of them together. So x minus 2 times x plus 1, and we make two identical fractions. So that's the denominator of both of them. Now I then look at this fraction here, 3 over x minus 2. Now x minus 2 has been multiplied by an x plus 1. That's appeared there, so we've got to make it appear at the top, so it's 3 times x plus 1. So effectively I'll multiply the top and bottom by x plus 1. Likewise over here we've got x plus 1. Now what's with it? I'm multiplying it by x minus 2, so I do exactly the same to the top line. Now once I've got two fractions with the same denominators, I can add the numerators to change it to one fraction, which is x minus 2 times x plus 1. And in the top, rather than just being numbers, we've got expressions, so we have to work them out. So it's 3 bracket x plus 1 plus 5 bracket x minus 2. And if I work out that top row, I get 3 times x is 3x, 3 times 1 is 3, 5 times x is 5x's, and 5 times minus 2 is minus 10. Denominator still staying the same, x minus 2 times x plus 1. And if we simplify all of that, we've got 3x's and 5x's, which gives me 8x. And I've also got 3 minus 10, which is minus 7. And the denominator still stays the same. and that's it expressed as a fraction in its simplest form. We're now going to solve a trig equation. So 2 tan x plus 5 is minus 4. So the first thing I want you to do is get rid of that minus, that plus 5. To do that, we take 5 away from both sides. So when I take 5 away from that side, I'm left with 2 tan x is equal to minus 4 minus another 5, which is minus 9. Now I've got to have tan x on its own, so it's 2 times tan x. The opposite of multiplying by 2 is to divide by 2, so that's equal to 9 divided by 2. We now work out our acute angle, which is your calculator angle. So calculator angle or acute angle is tan to the minus 1 of 9 divided by 2. We drop the negative sign, that's only used to work out which quadrant our answers are in. When I put that into the calculator, I get an acute angle of 77.5 degrees. Now we have to look at a cast diagram, okay, to see which quadrants that tan is negative in. So cast diagram is that there, and I know that they're all positive in this quadrant, which is between 0 and 90 degrees. Only sine is positive in the quadrant between 90 and 180 degrees, and tan is positive between 180 to 270. Cos is positive between 270 and 360. Now we're looking for tan is negative. So if tan is positive in there and positive in there, it's got to be negative in that quadrant and negative in that quadrant. So we've got an answer in quadrant 2, and I've got an answer in quadrant 4. That's where tan is negative. Now quadrant 2 is this one here, and the entry point into that is that way. Now there's a straight line, 180 degrees, so it's 180 minus 77.5. And in quadrant 4, the entry point into that is that way, which is 360 degrees minus 77.5. And when I work both of them out, the first one comes out to be 102.5. And this one here, 360 minus 77.5, is 282.5 degrees. Always write down your answers in a wee bracket, so x is equal to 102.5 degrees and 282.5 degrees. Now the reason I'm doing that is we've got another angle written down here, but that's not one of our solutions. That was just the angle we used to help us get our solution, so always finish it off by putting your final answers at the bottom. A perfume bottle has a label in the shape of part of a circle. The diagram of the label is shown below. Height of the label, and it gives us various dimensions. Now we've got to work out the height of that. Now these questions I call Pythagoras pipe questions. If you look down at the bottom, you will see a right angled triangle. Okay, and I'm going to highlight that so that you can see it. So there it is there. It goes from the centre out to the outside, and if we cut halfway across there, that's a right angled triangle. Now you always make that triangle, okay, and we'll use then Pythagoras. I'll draw it out at the side so that we can see it a bit clearer. And what we've got then is, we've got this side here is 6.6 centimetres, that's 6.6 centimetres. This wee bit here is our 90 degrees. Now going right across that whole part is 9, so we've got to halve that to get 4.5 centimetres. The question asks is the height of this label. Now from there to there, that whole part up there, that's the radius. That's the same as the radius. So if we work out this wee bit and we call it x, then the height of the thing is x plus the radius. Now it's Pythagoras, it's a shorter side, so to work out the shorter side we take away. So x squared is equal to 6.6 squared minus 4.5 squared. 6.6 squared is 43.56, and to that we want to take away 4.5 squared, which is 20.25. So when I take them away, I get 23.31, but I want to work out the square root of that. So square root of 23.31 is equal to 4.82. So we'll take it to one decimal place, so it's 4.8 centimetres. So the last thing for me to do is to work out the height and clearly show that the height is equal to x plus the radius, and x was what we've worked out, was 4.8 plus 6.6, that's the radius, you can see it there from the centre out to the outside of the circle, and that works out to be 11.4 centimetres. Now you will get a question like this, it's just got different context. This one is about a perfume bottle. They're called Pythagoras type questions. You can learn how to do them fairly easily. Now this question is at the end of the paper, so it's meant to be a wee bit more challenging and we need to put a bit more thought into it. Gives us a wee picture there, it goes through all of the different sizes and it asks us to calculate the length of BC, which is that side there. Now this is not similar triangles, okay, those are not sloping. Usually when you see a triangle within one, it's similar triangles, but not in this case. Now, what do we know? We want to work out the length of this big side. Now, in the big triangle, I know that side there, and I know that side there, and I want to work out a third side. Now, that should sound familiar. All three sides are involved. It must be the cosine rule. But what's missing? The thing that's missing is that angle in there. But they've told me that that's a right angle triangle, so I can use that right angle triangle to find that angle. So if we take a right angle triangle out from that, that there is 3, that there is 4, and if I call that angle A, then if we label our sides, that's adjacent, that's hypotenuse. So cos A is adjacent over hypotenuse, which is equal to 3 over 4. So if I do my shift cos, I can get angle A. So we've got cos to the minus 1 of 3 over 4. And when I do that, I get a value of 41.4 degrees. Now that then means that I can work out the sizes of that whole big triangle. Okay, so if we take the whole triangle there, we've got this side here is 4 and 6 is 10. That side here is 3 and 3 is 6, and I've worked out that this angle is 41.4 degrees. Now that means we've got a triangle here. I've put down 3 sides, I've labelled them, and I want to work out A. So from the cosine rule, A squared is equal to B squared plus C squared minus 2BC cos A. That formula is at the front of your information sheet. So B squared is going to be 6 squared. C squared is 10 squared minus 2, and I'll put a bracket around that, 2 times B, which is 6, times C, which is 10, times cos the angle we've just worked out, which was cos 41.4 degrees. Now there'll be 3 parts to this, and we'll work out each part in turn. Now you have got your 3 parts to it. When you put all of them into your calculator, you get 45.98667, and it goes on. I want A, which is the square root of all of that, so it's the square root of that number above, 45.98667, and it turns out to be 6.781. Now I go back up here and I look at the question again, and it says give your answer correct to 1 decimal place. So when you write your answer to 1 decimal place, you get 6.8 centimetres. And again, that's a mark for rounding. Don't miss it.